You know, we're always told the story of AI is about faster chips and bigger data sets. But what if the real revolution, the thing that's going to truly shake things up, is hiding somewhere else entirely? Today, we're diving into a new book by Edzai Zvobwo called Mathematics of Disruption. And it argues that the future of AI isn't about more brute force. It's about finding better, more elegant math.
And that idea right there, it pretty much challenges the entire Silicon Valley story we've been hearing for years. It's suggesting that the next massive leap in AI won't come from engineers building bigger machines, but from mathematicians discovering smarter equations. It's a total shift in how we should be looking at this.
So, to really get why new math is so crucial, we have to start with a truth that's kind of surprising. The incredibly powerful AI we use every single day is actually built on some fundamentally shaky ground. Let's go look for the cracks in the code.
I'm sure you've seen this happen. You ask a chatbot the same question twice, even with the creativity setting turned all the way down, and you get two slightly different answers. So what's going on? Is it being creative? Is there a ghost in the machine? Well, the book argues the answer is a lot simpler and way more profound. And there it is. That's the heart of the problem. Inside a computer, the basic arithmetic we all learned in elementary school doesn't quite work. And listen, this isn't a bug. It's a fundamental design choice that trades perfect mathematical precision for speed. This tiny, almost invisible little quirk is where the fragility of all modern AI really begins.
Okay, so this slide makes that abstract idea totally concrete. In pure math, the order you do this in doesn't matter. The answer is always going to be 0.1. But just look at what happens inside a computer. When you add that tiny number to a massive one, the tiny number just gets rounded away. It basically disappears. And the result? A completely different answer, 0. Now imagine an AI doing billions of these calculations. These tiny errors start to add up. The book calls this floating point fragility, which I love. It calls it the original sin of computing. See, to handle the huge range of numbers that we need for these complex tasks, computers use an approximation system. But that compromise, as necessary as it is, means that some of the sacred rules of math just get broken. So next time you see a chatbot give you two different answers to the same question, you're not seeing a ghost in the machine. You're seeing the shadow of all these tiny accumulated rounding errors.
So, if the foundation is this fragile, what's the solution? This is where our journey takes a really interesting turn, away from the problem and toward the search for a better mathematical toolkit, one that can build a more robust, more reliable AI.
The author uses this absolutely brilliant metaphor to describe the training process, which is technically called optimization. Imagine you're trying to find the lowest point, the point with the least error in this huge, complex mountain range. But you're blindfolded, and you can only feel the slope right under your feet. It's a pretty treacherous journey, right?
And this landscape is just filled with traps. You've got local minima, which are these little valleys that feel like the goal, but they're not actually the deepest point. Then there are settle points, these flat areas where the model just gets stuck, and something called vanishing gradients, where the slope just disappears and you have no idea which way to go. The methods we use right now to get around this stuff, they're mostly just clever hacks. It's like giving our blindfolded hiker a random push to get him out of a valley. It's not a real solution to the problem of being blindfolded in the first place.
And this brings us to the key insight. Just throwing more computing power at the problem, forcing our blindfolded hiker to run faster, that's not going to work. What we really need is a better map of the terrain. A map drawn from more advanced, more elegant mathematics that can actually guide us to the best solution without us getting lost along the way.
And that brings us to the book's most powerful argument. Where's this new map going to come from? Well, the author proposes a really surprising answer. From places that can't afford to hike blindfolded, places like South Africa, where constraint isn't a bug, it's a feature.
And right here, the contrast is just crystal clear. On one side, you've got the dominant way of building AI, which is all about abundance, huge data sets, endless server farms. But the African equation is born from constraint. When data is scarce and your network is patchy, you are forced to be smarter. You have to be more efficient, more creative. You have to learn from your limits.
So what looks like a disadvantage on the surface is actually a huge strategic asset. Constant power cuts or load shedding, they force engineers to build AI that is incredibly energy efficient. Having less data, that forces you to create models that can generalize from just a few examples, which is kind of the holy grail in AI research. A society with 11 official languages is the perfect laboratory to build language models that are truly inclusive. These constraints breed incredible innovation.
So, where does all this lead? Well,
The final part of the book pulls it all together into this powerful vision for the future, one that combines that mathematical rigor we've been talking about with a deeply human African philosophy.
The guiding principle for this new vision is Ubuntu. It's a philosophy that sees all of humanity as interconnected. Your well-being is tied to my well-being. And that leads the book to ask a really radical question. What would AI look like if it were designed not just for individual tasks, but with this principle of interconnectedness baked into its very core?
And this philosophy, it translates directly into a new set of design principles. So instead of prioritizing only profit, an Ubuntu AI is built for collective benefit. It has to be transparent so that communities can actually trust it. And it has to be inclusive enough for everyone to use. And, crucially, it must be sustainable. It has to work within our real-world energy limits, all while empowering people, not making them obsolete.
And let's be really clear here. This isn't just some feel-good ethical framework. The book argues it's a powerful competitive advantage. While the rest of the world might be building AI designed for extraction, extracting data, extracting attention, extracting profit, this model focuses on building AI for collective flourishing. And that creates a fundamentally different and potentially much more resilient and valuable kind of technology.
And the book leaves us with this final, kind of haunting question that's posed by the AI itself. It's a call to action. The future of AI isn't set in stone. It is going to be built by someone. The choice is whether we actively participate, building it with our own values and our own wisdom, or if we just wait around to use whatever others decide to build for us. And that's a question not just for one country, but really for all of us.